All right, so this is going to be the first of the review videos. There will be multiple topics to follow. And good morning, and I hope things are going well for you guys and that y'all are all staying safe. The order of the AP review is going to be the same order that we went through class. The very first thing we're going to do is collect data. Then we're going to display and describe the data. Then we are going to say what's the probability that we would get data that looked like that. And then ultimately we're going to do inferences or make decisions on that data. And that's where we run hypothesis tests and confidence intervals. So that will be the order. So first off, just want to let you know that for the collecting data unit, you should probably review your note spirals, beginning with pages 1 through 3, and then pages 11 through 38. Those in-between pages are on simulations, and you can kind of ignore those initially. The very first thing I want to do is talk about the purpose of statistics, and because it's something that I've seen people struggle with. Well, the purpose of statistics is this. We want to know something about the population. We want to know about the percentage of people who actually contract the coronavirus, or we want to know how many people are not who will die as a result of the coronavirus. So we're interested in that about the population. Well, we rarely ever know the actual value of the population, and unless we do a census, we won't. So consequently, we have to take a subset or a sample of that, and that sample is what statistics is all about. If we actually know the population values, we don't need statistics. But because we're typically working with a sample or a subset, we'll use statistics to determine the likelihood that we see data that looks like this. So the very first thing I want to talk about is this population versus sample. The big deal is populations have parameters, whereas samples have statistics. If we know the population parameter, we don't even need the whole entire subject of statistics. If we're working with a sample, which is a subset of this data, we are working with the statistic. Please remember that population values the parameters, and that's P for parameter, versus statistic for sample. All right, so population parameter, sample, statistic. These will all be Greek letters. So when we talk about a mean, we're talking about mu. And here we'll be talking about X bar. So anything with English letters, okay? All right, so since we're using a subset of the population, we are taking a sample. Well, how good is our sample as an estimate? Because we're using the sample to estimate the population. That's the purpose behind statistics, in order so that we can make decisions. Well, a good sample needs to be representative of the population. In other words, a good sample looks like the population, and the more it looks like it, the more it contains more of the elements of the population, the better our decisions, the better our inferences will be. A good sample could be small, or it might be very, very large. It just depends on the diversity of the population. Like if we wanted to survey if we wanted to take a sample of the male statistics teachers, well, a sample of 1 would actually be an entire census, but that would be a good sample because you would only need to see 1 person, and that would be great. If you wanted to know a sample of teachers at Reagan, you'd probably need multiple teachers. All right, so a sample could be very small or it could be very large in order to be representative of the population. All right, so one of the biggest problems we have is bias. We actually have 2 problems in collecting data, and bias and sampling error. Bias is where we'll start with first. And bias consistently overrepresent or underrepresenting a component of the population in the sample. However, bias is a result of either a design flaw, a flaw in the design of the study, or it could be the result of poor execution of the study, but it will consistently over or underrepresent a portion of the population, which and consequently that sample is not any good. So in sample surveys, what is meant by bias? Well, the first answer choice is natural variability seen between samples. Natural variability between samples is known as sampling error. That is not bias. So this is sampling error, and it's not bias. So it can't be A. Tendency for some distributions to be skewed. Well, some data is naturally skewed. Perhaps if we talk about income in the United States, it's highly skewed to the right because there are few people that make a lot of money. So that would be skewed to the right. So it's okay for data to be skewed. So that's not correct. Sorry, let me slide that up. Tendency for some distributions to vary from normality. Again, many distributions are not normal. For instance, when we roll a dice, it follows a uniform distribution. All the probabilities are equal, so not being normal is not a problem as far as bias is concerned. A systematic error in sampling method that leads to an unrepresentative sample. Yes, because this is just saying that, hey, in general, we have a design flaw in our sampling method that will lead to an unrepresentative sample. In other words, for whatever reason, we are either overrepresenting or missing part of the population. So this right here would be the best response, okay? And then prejudice, for example, in ethnic and gender-related studies. That is bias, but that's not statistical bias in the way we're talking about. So that's not the answer we're looking for. The best answer for this case is a systemic error in sampling method that leads to a unrepresentative sample. Avoiding bias. Well, we can avoid bias by creating and execute a well-designed study. That's the most important thing you can do. Design it well, and well-designed studies will all involve randomness, okay? So well-designed studies all involve randomness, and that will help, and that helps avoid bias. Bias in sample size. Increasing sample size will not fix problems of bias. That is really, really key. There's no way you can fix bias. It's kind of like this. Well, if someone and this is kind of a sad statement, but the fact of the matter is, let's just say someone has lung cancer. Well, that means that person has cancer. Yes, it's only a part of the person, but the whole person is considered to have cancer. All right? Bias it cannot be thrown out. Or perhaps you wanted to use the term racist. Well, they're a little bit racist. Well, if they're a little bit racist, they're racist. All right? You can't undo it by increasing the sample size. All right? And the only thing you can do with it, if you have it, is you have to throw it out. You have to start over. All right, types of bias. Well, we have voluntary response bias, and that occurs when anyone is allowed to self-select. They can allow to choose to respond to a question. So, for instance, on the internet, there are all these times there are the polls. What do you think of this? Do you like this? Etc. And the people that respond to those tend to have, not all of them, but tend to have extreme. They're either extremely in favor or they're extremely opposed. All the people that are more in the center, who are meh and are not as in tune to the topic, don't tend to vote on those things. It's only those who have extreme opinions, so they tend to be over-representative. All right, so it over-represents those with strong opinions in favor or against. So which of the following statements is correct? Convenient samples often lead to undercoverage bias. Convenient sample is just taking a sample that's easy to take, and that it tends to be true. It tends to overrepresent some part of the population, so consequently it does underrepresent part of the population. So we were looking for incorrect. This tends to be true, so this would not be our answer. Questionnaires with non-neutral worded questions are likely to have response bias. That's also true. That's the definition of response bias. And we'll get to that in a moment. Voluntary response samples often underrepresent people with strong opinions. That's false. All right? That is false. They tend to overrepresent. So this looks like this right here is going to be our answer, because that's false, and we're looking for a false. There is no way to fix the results of a bias sampling if a bias sampling method was employed. That's true. Non-response bias should be avoided because those who do not respond might have different views from those who do respond. That is also true. So we look at that, and letter C is our answer to that. Okay, moving on. Response bias occurs when questions are not neutrally worded and lead people to a particular response, or when the question involves an uncomfortable topic that causes people to misrepresent the truth. All right, so this is when the question is not, if I word the question in a specific way, I can change some people's answers depending on how I word the question. The other thing is if it's a sensitive topic, people may not want to give me the truth, and so they will lie. So, two possible wordings for a questionnaire on a proposed school budget increase are as follows. The school district has one of the highest per student expenditure rates in the state. This has resulted in low failures rates, high standard test scores, and most students going to good colleges and universities. Do you support the proposed budget increase? Well, that's a fairly positive. This school district has one of the highest per student expenditure rates in the state. This has resulted in a high property taxes, with many people on fixed incomes having to give up their homes because they cannot pay school tax. Well, this is worded in a negative. So this one says, do you propose, so this is negative, this is positive. So I'm thinking more people are going to be in favor of the first one, and fewer people are in favor of the second one. All right. So one of these questionnaires showed that 58% of the population in favor of the proposed school budget, while the other question showed that only 13% of the population were in favor, which resulted in which question and why. Well, the first showed 58%, and the second showed 13%. Because of response bias due to the wording of the question. So this looks like this is going to be my answer. The first showed not as evidenced by we don't know anything about randomization, so that one can't be it. This is wrong. The first showed 58 and the second showed 13% because of the lack of a control group. It's not an experiment, so we wouldn't have one. It's a survey. The first showed 13%, and so this is the wrong percentages because these are swapped on the percentages. So the only one it could be is letter E. All right, I'm going to have to shut down the video just because, and we'll go to this. We'll start here in the next video due to the time limit on YouTube. Thank you.